All right, so this video is going to be about polynomials and their end behavior. And the first thing I want to talk about is, what does end behavior mean? End behavior means that what happens at the ends of the function. Well, what does that mean? So if you have a graph, here's your coordinate plane, your x and your y axis, and you have a graph, say it goes like this. It means that we just want to focus on the ends, okay? So it doesn't really matter what happens in the middle. So all of this, what I'm about to put in blue here, all of this here doesn't mean anything when we're talking about end behavior. So when you see end behavior, you kind of just want to cloud this out, the center of the graph. You want to just focus on the ends. And what you're gonna, basically the only thing you have to focus on the ends is, do they both go in the same direction or do they go in opposite directions? So in this case of this one that I just drew, those go in the same direction because both of the ends of that function go down. All right. So that's how we would describe the end behavior. So it says, what is the end behavior of this function or this polynomial? We would say, for now, I would say that both of the ends go down. Okay. And you could also have one that looks similar, where they both go up. All right, that's kind of the same thing. These both go down, these both go up. They both go in the same direction. So, and that's going to tell us something here in a second that we talk about. So that's what end behavior is. And we're actually going to describe the end behavior in mathematical terms. So where can a graph move? A graph can move in 4 different directions: left, right, up, and down. Okay, now if you think about left and right on the coordinate plane always has to deal with the x. That's where the x-axis is. The x-axis goes left and right. And the y-axis is the one that goes up and down. So how we're going to describe end behavior, how we're going to describe the graph moving to the left, again, moving to the left affects the x. We would say as x goes to infinity. As x goes to infinity, that's just another way to say that the graph goes to the left. And to the right, actually, I just made a mistake. As x goes to negative infinity. Okay, because if the x is moving to the left, the numbers are getting smaller and smaller and smaller into the negative, so they're going to negative infinity. If you're going to right, you would say as x goes to positive infinity. All right, these are just other ways to describe the movements of the graph. So left as x goes to negative infinity, right as x goes to positive infinity. Now up and down, kind of the same idea, but we're going to describe why. So this is another way to say as y goes to positive infinity. Because if you think about a graph, and you think about a function moving up, that means the y is getting larger as the function is moving up. And therefore, this one is as y goes to negative infinity. Okay, and what we're going to do is we're going to go over 3 different graphs here in a second, and we're going to use these terms to describe the end behavior. All right, so again, left, x goes to negative infinity. To the right means x goes to positive infinity. Up is y goes to positive infinity, and down is y goes to negative infinity. All right, so here's a graph on the right-hand side. Again, it doesn't matter what happens from here to here. Okay, that doesn't mean anything when we're talking about end behavior. All we care about are these ends. And if you notice, they're both going up. Okay, how I'm going to describe this end behavior on the left-hand side, again, what is x doing? Well, as this graph goes this way, x is moving to the left, and y is going up. Okay, so if you remember left and up, how do we describe left and up? Well, how we described left was to say as x goes to negative infinity, okay, and it's also going up, so we're going to have to describe the up. So as x goes to negative infinity, comma, y goes to positive infinity. Okay, that was describing the left end behavior, what happens on the left-hand side. Okay, now I'm going to change colors here. We'll go with a dark blue. Now we're going to describe this end behavior. What's it doing? It's going up. And which direction is it going? It's going to the right, correct? To start at the end, as we follow this graph, which directions are we going? We're going up for sure, and we're also moving to the right. So that's up and right. And if you go back to the last slide, we're basically just going to use those words to describe up and right. So we always want to describe the x first. We want to say as x goes to positive infinity. Again, that's describing to the right. X goes to positive infinity. Y goes to positive infinity. Okay, that's just how we're going to use mathematical terms to describe the end behavior of a graph. It's just a fancy way to say up, left, right, and down. All right? Let's do another one here. Okay, you'll notice this one's a little different. Over here, we're moving to the left, and we're going down. And for the other one, we're going to the right and up. Okay, so this one's going to be a little bit different than the one we just did. So to describe the one in blue here, left and down, so left, that's x goes to negative, I'm just going to abbreviate, negative infinity. Y goes to negative infinity, right? The y is up and down, so it goes down. So the y values as I'm moving here are going smaller and smaller and smaller and smaller. And what are they approaching? They're going to approach negative infinity as this graph continues down. The x, this is going, it's not going to the left very fast, but with an arrow here, that means it's going to continue forever and ever. So it's just going to continue working to the left and left. Smaller and smaller numbers, that's also negative infinity. So this is describing that end behavior. And the other one, we're going to the right. So that is x goes to positive infinity. And up is also positive. So y goes to positive infinity. Okay, so when you're describing end behavior, you should first say where x goes, and then as x goes in that direction, which direction does y go? So you want to say, as x goes to positive infinity, y goes to negative infinity up here. As x goes to negative infinity, y goes to negative infinity. Okay, that's how we're going to describe end behavior. One more thing to go over with this video is what end behavior actually tells us about what the function is, or what the function is going to look like. So here's Desmos, here's graphs of 5 different functions, okay? You'll notice if you look at the end behavior of the functions as a group, if you look at the right-hand side, over in this area, you see the black, the purple, the green, the blue, and the red. If you notice, their end behavior is all the same. They're all going up. Okay, so looking at the right-hand end behavior is not going to tell me anything about how I can group these functions. But if I look to the left, I'll see I have 2 functions that go up. Actually 3. I have red, green, and black. And I have 2 functions that go down. So the left-hand end behavior is what's going to tell me something about these graphs. And what I want to do is I want to figure out what's similar about these 3 graphs that makes them go up. And what's similar about these 2 that makes them go down. So what I'm going to do is I'm going to click on this. So I click on the red one, and it tells me that that's y equals x squared, okay? The green one, or the black one, is y equals x to the 6th. And the green one is y equals x to the 4th. Do you notice anything about x to the 2nd, x to the 4th, and x to the 6th? If the answer is no, then just wait until we do the other group here. So let's look at the other group. Purple is x to the 5th. Blue, if I can click on it, Blue is x to the third. Again, so x to the third and x to the fifth both go down. X squared, x4, x to the sixth all go up. So my question is, what if I type in something along the lines of y equals x to the, what if I type in the number 11 here? Tell me if you think the left-hand side of that graph is going to go up or down. It's going to have to go one of the two directions, up or down. So when I type in 11 in here, the left-hand side of this graph, where's it going to go, up or down? And look, it went down. So these three down here, if you look, what we're focusing on is the exponents if they're even or odd. So if you notice all of these ones that go up, they are even degreed. Remember, the highest power of the exponent for your polynomial, that's called a degree. So these all have even degrees. This one's a 2, this one's a 4, this one's a 6. All the ones that go down are odd. So 11, 5, and 3 are odd. Okay, and what I'm going to focus on is, let's delete all these. The even degreed functions, what do you notice about their end behavior? So look at this one. They both go up, right? About 4, both go up. About 6, both go up. About 8, both go up, right? So I can keep doing this, but it's going to be the same thing. What if I put a negative out front? It's still going to have the same degree. Oh, it flipped it upside down, but if you notice, both ends still go in the same direction. Okay, so that is something important. As long as it's even degreed, your end behavior is going to be in the same direction. Whether it's up or down, it doesn't matter. They're still going in the same direction. For odd degreed, the easiest way to remember this is odd and opposite. Odd and opposite have they both start with O. So odd degreed functions will go in opposite directions. See, so it doesn't matter if I put a negative, it doesn't matter if this is a 9. If it's odd, they're going to go in opposite directions. Okay, so that's very important. So what we're going to do is we're going to go to this last one, and we're just going to say, is this going to be an odd or even degreed function? Okay, so what we're looking at again is to tell this, we're only looking at the end behavior. That's all we care about. We don't care about all these bounces. Okay, we're not going to learn this, but the amount of times that this changes directions helps you figure out almost exactly what the degree will be. But we don't care, we just want to know if it's odd or even. What do you notice about these? They go in opposite directions. So that means that it's an odd degreed function. Okay, this could be like a y equals x to the 7, or it could be like a y equals x to the 9. We don't know exactly, we just know that power, the degree of the function, has to be odd because they're going in opposite directions. Let's just review the last two that we did. So look, this one has an end behavior. They're going in opposite directions, so this is odd degree. And this one, they go in the same direction. They both go up, so that means that this is an even degree function. Okay.